So now we've discussed the idea of building a decision stump from data and a little bit of what that data set looks like. Let's discuss now how do we pick the right feature to split on when we're building a decision stump. So we're trying to learn a decision stump from data, and here we split on credit, but the question is, what is the best feature to split on, and how do we measure that? So in our example, we split on credit, but we could have split on something else. Let's say we could have split on the term of the loan. Is this a 3-year loan or a 5-year loan? And the question is, what is better between the two? What is a better split? And that's what we're going to ask next. And intuitively, a better split is one that gives you lowest classification error. And that's exactly what we'll explore in the algorithm. We'd like to figure out whether it's better to split on credit or split on term. And the way we're going to do that is by measuring the number of mistakes each one of the decision stumps makes and pick the one that makes the least number of mistakes, or has lowest error. And just remember, the error is just the number of mistakes a classifier makes divided by the total number of data points. So let's start with the root node, and this is if we made no splits on a decision stump and measure the error that we get in that example. So as a reminder, we're going to predict y hat to be the majority class associated with a particular node. So in our case here, the class that has most values for the root is going to be the safe class. And we're going to compute the classification error of making that prediction. So here, what is classification error? We're just saying that all the data points are safe. So we can go ahead and say that there are 22 correct things, 22 were safe, and 18 mistakes. So the classification error here is going to be, I'm going to change colors, is going to be 18 divided by 22 plus 18, which is 40. So 18 over 40, which is 0.45. It's a binary classification problem. You only get 0.45, you get 0.45 error, which is really bad. And so not splitting on anything gives you a pretty bad result. So the question here is, how good is the decision stump that splits on credit? And how does it compare to not splitting on anything, which had a classification error of 0.45? Is this one better? So let's look at the decision stump. For data points that have excellent credit, we're going to predict that they're safe. For those that have fair credit, we're going to predict that they're safe. And for those that have poor credit, we're going to predict them to be risky. And so this is our prediction. And this is, again, the majority value of the data in each one of these nodes. And if we look at how many mistakes we make, you see that for the data that had excellent credit, we make 0 mistakes because everything was safe there. For the data that had fair credit, we're going to make 4 mistakes. There were 4 risky loans with fair credit. And for the data that had poor credit, we'll see there's 4 mistakes again because there were 4 safe loans when we had poor credit. So let's compute our overall error. We're going to write over here. I'm just going to change my colors. And we'll see that we make 4 plus 4 mistakes. So that's 8 out of 40 data points. So that's an error of 0.20, 0.2, which is lower than we had 0.45. So we've gone down now from 0.45 to 0.2. So splitting on credit seems like a pretty good idea. Now let's see what happens when we split on term of the loan. When we split on term of the loan, if the term is 3 years, maybe there was 16 safe loans and 4 risky ones. So in this case, we're making 4 mistakes. And for 5 years, we predicted risky, but there were 6 safe loans. So now we're making 6 mistakes. And so if you look at our overall error here, it's 4 plus 6 divided by 40. So that's 10 divided by 40, which is 0.25. So overall, if we look at our data, not splitting on anything, the root node has 0.45 error, splitting on credit has 0.2 error, and splitting on term has 0.25 error. So we can go back and ask, what is the best choice? Should we split on credit or should we split on term? The answer now becomes obvious. Splitting on credit gives you lower classification error, so this is what our greedy algorithm will do first. This is first feature to split on. And that will be the winner of our selection process. So in general, the decision tree splitting process will say, given the subset of data at node M, which is what we're looking at the root node so far, we try out every feature xi, which in our case here was credit, term, and income. And I consider splitting the data according to the possible values of each one of these features. And I compute the classification error of the resulting split, just like we did manually over here. And then I pick the feature, which in our case was credit, which had the lowest classification error. So if we go back to our decision tree learning algorithm, that first challenge that we had, figuring out what feature to split on, we can now do that using this feature split selection algorithm that minimizes the classification error. So next we'll explore the other parts of this decision tree learning algorithm.